The following video presentation will be covering the proper commissioning procedures for the Panasonic Ecoi VRF systems. The Panasonic Air Conditioning Division offers both phone and on-site commissioning assistance. Any on-site Ecoi commissionings will have a specific fee-based structure depending on the number of systems to be commissioned and control scheme utilized. The installing contractor must complete, sign, and return this Ecoi startup checklist prior to the commissioning of these systems. This slide and the following two slides show all of the different items which require completion prior to any on-site commissioning requests. Prior to any Ecoi VRF system being commissioned, all of the refrigerant tubing must be leak tested using dry nitrogen to a maximum pressure of 450 psig. This pressure should be applied to the system for a minimum of 24 hours. The refrigerant tubing must also be evacuated down to a minimum of 500 microns utilizing a micron vacuum gauge to measure the exact level of vacuum achieved. The triple evacuation method is strongly recommended. Also, on outdoor units which are doubled or tripled together, the oil equalization line which is connected between the outdoor units must be evacuated as well. On any of the Panasonic Ecoi VRF systems, there will always be an additional calculation in order to obtain the proper refrigerant charge. This additional refrigerant charge amount will be based on the type of outdoor unit installed. This slide shows all of the two-way outdoor models currently available and the different parameters required in order to determine the exact amount of additional refrigerant a system would require. This slide shows all of the three-way outdoor models currently available and the different parameters required in order to determine the exact amount of additional refrigerant a system would require based on all of these combined parameters. This is the calculation table used for determining the additional refrigerant charge for the mini Ecoi outdoor units. In order to determine the additional refrigerant charge required, all of the installed liquid line diameters and lengths must be considered. Each liquid line tubing diameter and length will then be multiplied by the associated adjustment factor based on the refrigerant piping diameters installed, as shown here in this example. The two-way and three-way models shown here in the 6-ton through 12-ton capacities will require an initial refrigerant charge for each outdoor unit installed as shown here in this slide. On installations using the 6 through 12-ton two-way or three-way outdoor units, the total combined indoor unit cooling capacity in BTUs per hour must be totaled together for each refrigerant circuit. The indoor unit's total BTU cooling capacity can then be inputted into the formula as shown here in this example. On both the two-way and three-way outdoor models in the 6 through 12-ton capacities, all of the liquid line lengths and diameters must be calculated in determining the additional refrigerant charge amount. All of the liquid line tubing diameters and lengths will then be multiplied by the associated adjustment factor for each diameter utilized as shown in this example. On the three-way outdoor models in the 6 through 12-ton capacities, all of the discharge line lengths and diameters must be calculated in determining the additional refrigerant charge amount required. All of the discharge line tubing diameters and lengths will then be multiplied by the associated adjustment factor for each diameter utilized, as shown here in this example. This slide shows all of the combined refrigerant charging tables utilized for calculating the additional refrigerant amount for the Ecoi VRF systems in the 6-ton through 12-ton outdoor models. This information can also be located within the installation manuals. This slide shows all of the total combined calculations which would be required in determining the additional refrigerant charge amount for the three-way systems in the 6 through 12-ton models. This calculation shows using just a single outdoor unit. However, these outdoor units, when connected together, can provide up to a maximum BTU capacity of 30 tons. The following slides will be covering the required settings for the Ecoi VRF outdoor units for the commissioning of these systems. This slide shows all of the items that should have been completed in regards to the refrigerant tubing prior to the commissioning and startup of the system. This slide shows a summary of all the wiring and power requirements which need to be completed prior to the commissioning of any Ecoi VRF system. The next step will be to configure the system through the rotary dials and dip switches for selecting a refrigerant circuit address, showing the number of connected indoor units and the number of interconnected outdoor units on larger tonnage systems. Once all of these settings have been completed, the system will now be ready for the auto-addressing process. The following slides will provide a step-by-step procedure for configuring these systems for commissioning. The following slide provides a definition of Panasonic's frequently referenced addresses and different terminology. This information will assist in providing a better understanding as to how these systems communicate using these different types of addresses. The following slides will show the required dip switch and knob settings on the main outdoor unit's printed circuit board, which are utilized during the initial commissioning of these mini Ecoi VRF systems. This slide shows the different dip switch and knob settings utilized for assigning a refrigerant circuit address from 1 through 30, along with the total number of connected indoor units from 1 through 64 as required on the larger tonnage Ecoi VRF systems. Note that some of the other dip switch settings on the main printed circuit board will be set to either an on or off position based on the system's configuration. Shown here is the main printed circuit board for the mini Ecoi outdoor unit. The refrigerant circuit address is set through the black knob and dip switches abbreviated as RCADD S002 and S003 on the main printed circuit board. The number of connected indoor units is set through the red knob abbreviated as NO of IU S004 on the main outdoor unit's printed circuit board. These particular settings apply to the mini Ecoi outdoor units. Once all the dip switches and knob settings are set, the system is now ready to be auto-addressed. The auto-addressing procedure is initiated by shorting across the A.ADD pins for 7 to 8 seconds. Once the A.ADD pins are shorted together for 7 to 8 seconds, the LEDs 1 and 2 on the main outdoor unit's printed circuit board will begin to alternate back and forth. Once all of the indoor units on the refrigerant circuit have been successfully addressed, then LEDs 1 and 2 will go completely out on the main outdoor unit's printed circuit board. At this point, the system is ready for startup. Once all of the indoor units on the refrigerant circuit have been successfully addressed, then LEDs 1 and 2 will go completely out on the main outdoor unit's printed circuit board. At this point, the system is ready for startup. In the event the outdoor unit is unable to assign all of the connected indoor units with an indoor unit address, then LEDs 1 and 2 on the outdoor unit's main printed circuit board will begin to blink a certain number of times to reveal the error message. LED number 1 can blink anywhere from 2 to 6 times, which reveals the letter code, while LED number 2 can blink from 1 to 31 times. The error message will also be shown at any of the indoor units which utilize the hardwired remote controllers. The two-way and three-way outdoor units will also have a series of dip switches and knob settings on the outdoor unit's main printed circuit board, which will need to be configured during the commissioning process. The outdoor unit is recognized by a designated refrigerant circuit address. This refrigerant circuit address is assigned by setting the black knob and/or dip switches abbreviated on the main printed circuit board as RC, ADD, SW1, and SW2 as shown in this slide. The indoor unit addresses will be assigned randomly by the outdoor unit's main printed circuit board during the auto-addressing process. The outdoor unit's main printed circuit board must have the correct number of indoor units indicated prior to addressing the system using the red knob and dip switches abbreviated as NO of IU, SW3, and SW4 as shown in this slide. The maximum number of indoor units which can be set up for an Ecoi two-way or three-way system in the larger tonnage capacities are shown here within this slide. When the two-way and three-way outdoor units are doubled or tripled together, the SW6 dip switch abbreviated as NO of OU has to be set to reflect the total number of interconnected outdoor units as shown in this slide. When the two-way and three-way outdoor units are interconnected, one of the outdoor units must be defined as the main outdoor unit. The main outdoor unit will always be designated as the only outdoor unit to communicate back and forth with the connected indoor units. This designation is completed by utilizing the SW5 dip switch abbreviated as OU.ADD on the main printed circuit board. The remaining interconnected outdoor units will be defined as slave units through this same dip switch. These different dip switch configurations are shown in this slide. This is an illustration of two outdoor units which are doubled together, showing how the S005 and S006 dip switches would be configured on both the main and sub outdoor units. The auto-addressing process is initiated through the A.ADD pins on the outdoor unit's main printed circuit board. These pins must be shorted together for approximately 8 to 10 seconds, at which time LEDs 1 and 2 will start to blink back and forth alternately. The LEDs 1 and 2 will go completely out once the system has been successfully addressed to all of the connected indoor units. This slide shows the location of LEDs 1 and 2 on the main printed circuit board for the two-way and three-way outdoor models. These LEDs are used during the auto-addressing process to determine if all of the connected indoor units were assigned an indoor unit address or not. If one or more indoor units are not located and assigned an indoor unit address, these same two LED lights will each blink a certain number of times to reveal the error message. LED number 1 blinking 2 to 6 times for the letter of the error message, and LED 2 blinking 1 through 31 times to reveal the number of the error message, as shown in this slide. This slide shows how the outdoor unit's main printed circuit board assigns the indoor unit address to each of the connected indoor units. When checking the assigned address at the indoor units when installed with the wired remote controller, the first number will always represent the refrigerant circuit number, while the second number will reflect the indoor unit's address. The following slides will show how the refrigerant circuits get linked together at the low voltage wiring terminals on systems that are utilizing a Panasonic centralized control device. The first step is to auto-address each refrigerant circuit by assigning a different refrigerant circuit address to each outdoor unit and setting each outdoor unit to reflect the correct number of connected indoor units. Next, verify that each refrigerant circuit has been auto-addressed with no error messages present and that each refrigerant circuit will operate when selecting a cooling or heating mode at the remote controller. Once proper operation has been verified, Next, link the low voltage wiring from each system together at each outdoor unit's low voltage wiring terminal strip with an 18 gauge 2-conductor stranded and shielded wire. Once the refrigerant circuits have been linked together, the next step is to commission the centralized control device. The different Panasonic centralized control devices will have a procedure for assigning a central control address to all of the indoor units being monitored and controlled. This central control address will be used for the communication taking place between the central control device and all of the indoor units. On systems where the low voltage communication wiring U1 and U2 is linked together between multiple refrigerant circuits, the open short jumper position on the main printed circuit board will need to be changed from the factory shorted position to the open position on all of the refrigerant circuits but one. One system must remain in the original factory shorted position. This slide shows 5 different refrigerant circuits where the low voltage communication wiring U1 and U2 have all been linked together, forming one large communications bus. Here, 4 of the open short pins have been repositioned on the main printed circuit board to the open position, leaving the last refrigerant circuit in the original factory setting of shorted. The Ecoi VRF systems will display the different error messages at the indoor unit using the Panasonic hardwired remote controller when installed at the indoor unit or when being utilized as a service tool. Also, these same error messages will also be displayed at the main outdoor unit's printed circuit board through LEDs 1 and 2 as mentioned earlier in this presentation. The Panasonic wired remote controller model CZ-RTC4, when used with the wiring harness part number 623-178-5082, can be utilized as a service maintenance tool. Once the wired remote controller is plugged into the RC connector at either the indoor or outdoor unit's main printed circuit board, it can then be utilized to monitor information being reported back to the board, view the error message history, and also access the EEPROM chip to make any necessary changes. This is one of the error messages which may occur during the auto-addressing process while commissioning these Ecoi VRF systems. The E15 represents that the outdoor unit was unable to find one or more indoor units during the auto-addressing process. This slide shows if all of the indoor units have hardwired remote controllers installed, the remote controller with the blank screen would indicate the problem unit. This slide shows many of the possible causes of why the system would show an E-type communications error message. Another error message which can occur at the time of commissioning on the larger 8 through 12 ton 3-phase outdoor models is a PO5. When a PO5 is shown, this error message represents that there is a phase imbalance or possible missing phase. This is corrected by reversing any 2 of the 3 incoming power supply wires at the L1, L2, and L3 wiring terminals of the outdoor unit, or this can also be done at the disconnect switch. Once the system is up and running, it is very important to make sure the system is operating with the proper refrigerant charge amount. The typical R410A refrigerant manifold gauge set should not be used when trying to determine if the refrigerant charge is correct or not on the Ecoi VRF systems. The pack checker tool is used for evaluating issues which can occur within the refrigerant system while in operation. Some of these items are low refrigerant charge, stuck valve positions, low compressor oil levels, identify indoor units operating in the freeze prevention mode, delta T across the evaporator coil, evaporator superheats of the indoor units, initiate a test run mode, see any pre-trips or current alarm conditions, and for logging data which can be saved to a PC or laptop. This slide shows a screenshot of all the information which can be monitored once the Pack Checker tool is connected to a system. All of the parameters for the indoor units will be displayed in the top section of the display screen, while all of the outdoor information will be viewed in the lower section of the display screen. Thank you for watching this training video on the commissioning of these Ecoi VRF systems. Please refer any questions you may have pertaining to the information portrayed within this video to the Panasonic Technical Support Air Conditioning Division. Thank you for your business and have a great day.